Given this I of S and the equivalent admittance, we need to calculate the average power absorbed or delivered by the 10 ohm resistor right here. Looking at the diagram, something we should note is that the voltage flowing through here, the source voltage, is going to be the same as the voltage in this 10 ohm resistor. So we can have plus minus V right here, and they are the same. That means we can find the actual V here and then use it to find the power in here. That's how I'm going to look and solve for this problem. So we are given admittance. Well, admittance is equal to impedance, but impedance divided by 1. So it's 1 over impedance. And impedance, we know, is equal to Z. So we are going to have 1 over our Y equivalent, and this is basically going to be 1 divided by 0.2166 at an angle of 6.12 degrees. We can have 1 over 0 degrees if we convert this to polar form. And we know that we're going to divide the numbers and subtract the denominator angle from the numerator angle. This will give us a 4.62 at an angle of negative 6.12 degrees. So that is the Z equivalent, and that is the total impedance if we were to add all of the impedances together. Now that we have this, and we are given our source current, which we know, I of S, to be 20 at an angle of 6.12 degrees, we can find the voltage right here. And it's, again, the same that's right here. So voltage is equal to current times resistance. Voltage is going to be equal to the 20 at an angle of 6.12 degrees, and we'll put this in parentheses, times 4.62 at an angle of negative 6.12 degrees. And this is going to give us that our voltage is equal to approximately 92.34 and an angle of 0 degrees, so we don't need to write this down. That is our voltage. Now, to find power, we know that power is P, and P is equal to voltage times, not resistance, sorry, voltage times current. We don't have a current here. We just have an I1, not very useful. We could solve this with currents, but this is so much simpler. So what we can do is substitute for our I. We know that I, using Ohm's law, is equal to voltage over resistance. So we'll rewrite our power formula as P is equal to V squared, voltage squared, divided by resistance. So we can plug our values in. P is equal to our voltage, which is 92.34 squared, divided by the resistance, which is just 10 ohms. And this is going to give us approximately 853. It doesn't really affect this problem, but it's important to note that the voltage here that we found is a negative. It's a negative 92.34. And the reason that it's a negative is because we were solving for this voltage, and this voltage drop is going in the opposite direction of our current voltage drop is from positive to negative. And when they're opposite directions, it produces a negative. However, this voltage right here with this current is in the same direction. So our answer will be a positive approximate 853. It's just important to note. That's how you would solve this problem.